Hey everyone, it's Mr. Cowblin here again, and today I will be presenting the last topic for this chapter dealing with the basic trig ratios. And what we're going to do here, we're going to put everything together and we're going to look at some word problems where we're actually going to see all three ratios at work depending on what information is provided for us in the word problem. And basically what I want to do here is that when we're taking a look at any type of right angle triangle, that we know what plane to use in order for us to solve the problem that is presented to us. So let's get right to it here. So again, what we're going to do for today is just take a look at various problems using the basic trig ratios and then look at how to use them. All right, so again, with the basic trig ratios, again, the first thing we need to do is just make sure our calculator is in working order here. So make sure it's in degrees mode. Okay, we're pressing the DRG key until you get the DEG. Okay, reset the calculator if you need to. Okay, and different calculators have different ways to reset. Typically, there's a hole you can just poke something sharp with. All right, so in today's lesson, we will be looking at the various ratios with the information that's given to us in a word problem. So we'll be exploring all three ratios in one lesson so you can see exactly what tool to use for what types of information that's given to us. All right, and those are the three keys that we've been using for the last two lessons, including today. And remember, in order for you to solve for an angle, you have to also press the second function key to take what's called the inverse of any of those three trig ratios, and then from there that will solve for the angle. All right, so what are we going to do for today? We're going to take a look at the fact that we are going to be looking at various problems where we need to pick one of the three ratios in order for us to use over here. Now, we're going to start off with some basic terms here because, again, there are word problems. So some of the questions you'll be seeing, there's going to be some terms that you do need to familiarize yourself when it comes to angles. So the first type of angle that you need to familiarize yourself is what's called the angle of elevation. Now, what the angle of elevation is, okay, it's the angle that's in between the horizontal or the line that's going straight forward from the person's line of sight or where they're seeing, okay, and the side that is going up to wherever this person or object is looking at. Okay, so think about it this way. If you're looking straight, okay, and then you look up at, let's say, the top of a tree, okay, the angle between where you're looking straight and where you're looking up at the tree, that's an example of an angle of elevation. So all these the next angle as well that we're going to see here, the angle of depression, okay, is also going to be with respect to the horizontal. Now you notice I've indicated there with a red line what the horizontal is, and I guess all the horizontal is a line from the person's line of sight. Okay, so from their eye level. Okay, so the angle of depression, okay, which is again just a way think about it looking down. Now, this is of the two angles, this is the one that people have a hard time remembering. Okay, the reason for this because yes, you are looking down. However, you are looking down from the horizontal. So let's just say you're looking straight ahead and then you look down on the ground. The angle between from you looking straight ahead and the angle as you're to the object that you're looking down there, that is the angle of depression. So if you take a look at the diagram there, notice I'm going to indicate the horizontal with a red line. Okay, and the angle of depression, again, as I said before, is the angle between the horizontal and the line that's going down to the object that you are looking at, okay, or on the ground. Now, with respects to angle of depression, okay, we're actually going to revisit something that you were introduced to uh, either in grade 8 or grade 9, okay, dealing with what was called the Z pattern. So typically, when you have an angle of depression, okay, you also have an equal angle of elevation somewhere else in the diagram. So we're going to look at a question where we're actually going to apply that in a certain situation here. All right. Now, what we're going to do for today, it does involve word problems. So we know in the word problems that we're going to see here, it's all going to involve right triangles somewhere in the question. We just need to know, again, where it is by sketching a diagram, okay, identifying the angle that we are referring to, whether we are solving for it or it's given to us to help us solve for the length of a side, okay, and then from here, identify what sides we have and then what ratio we're going to use based on the given sides. Okay, so starting off with the first example, okay, we're going to look at the height of a tree over here, as you can see. So from a point 10 meters from the base of a tree, the angle of elevation to the top of the tree is 40 degrees. Now, when you're looking at this question here, notice there's a couple of things that stand out. Obviously, the measurements, okay, 10 meters from the base of the tree. Start off with that, okay? Now, anytime you hear angle of elevation, remember that the angle of elevation is the angle between the horizontal, okay, and the line that's going up. So if you take a line going up, meaning the slant. So in this case over here, okay, what we have here that I've drawn here for the 10 meters, that is the horizontal. So the angle of elevation is the angle between that line, okay, and the slanted line that's going up to the tree like this. So the 40 degrees is going to go there. And the height of the tree is the vertical distance, which is going to connect those two sides to make a right angle there. All right. So let's solve for the height of the tree here. So let h represent the height of the tree. Now, if you take a look at the 40 degrees, we need to label the h and the 10 with respects to that angle. Now, remember when we were dealing with the sine and cosine lesson, we always labeled hypotenuse first. So if you look at this diagram over here, notice this is the box and we look directly across from it. This would have been the hypotenuse, but unfortunately, there's no information there. So we do not need to label it. So we do need to know for h and 10, which one's the opposite, which one is the adjacent. Now, if you look at the 40-degree angle, remember the side directly across from that is going to be the opposite. So with that said, okay, in this case, the h here would be our opposite and our 10 here would be our adjacent. Now, remember we broke down all three trig ratios in two separate lessons over here. So if you take a look at the three ratios, you pick the ratio that has the opposite and the adjacent. Okay, and as you can see in this case here, that would be the tangent ratio. Okay. All right, so next part we're going to put the numbers in for the respective letters there. So the opposite here will be h, adjacent here will be 10 meters, and the 40 here will go for the capital A. Now remember this next step here, you only do when you're solving for the length of the side. So this over here, I'm going to put 1 underneath it. Okay, and then from there, we're going to cross multiply. Okay, and when we multiply the h to the 1, it gives us h, and then we get 10, 10, 40 degrees on the other side. And then carefully plug that in your calculators, 10, 10 of 40 degrees, and you should get 8.4 meters. All right. So notice again, we started off with a diagram, labeled the sides, and then pick one of the three ratios based on the information that's given to us. Okay, and then from there, put in the numbers and then solve for, in this case here, the side. All right, let's take it up a notch over here, and let's take a look at another one. So we now have two buildings. Okay, so what do we know about the two buildings? Well, one is taller than the other one. Okay, that's a start. Now, two buildings are 125 feet apart. So let's start off with that. Okay, so again, always label according to anything with a number there and make sense of what we have. Now, the next part is going to be a little bit challenging to understand at first. That's why I do need to break this part down here. So between the two buildings, it says from the roof of the shorter building, the angle of elevation to the top of the taller building is 45 degrees. So let's start off with that. So if you take a look at the smaller building, okay, from the roof of it, the angle of elevation to the top of the taller building is 45 degrees. Now, just like the previous question, remember anytime you hear the word angle of elevation or the term angle of elevation, the first line that you should draw is a horizontal, okay, which is a line going directly across. So from the top of the smaller building, you're going to draw a line going straight across like so. Okay, so that's step number one. Okay, step number two, what we want to do next over here is to draw the slant. Okay, and this will be this will help us understand where the angle of elevation is. Now remember, the angle of elevation is the angle between the horizontal and the slant going up. So that means our 45 degrees is going to be there. Okay, so we've taken care of that part. Now the next part, okay, the angle of depression to the base of the taller building is 30 degrees. Okay, and again, this is from the roof of the shorter building here. Now, in a similar fashion to angle of elevation, anytime you hear the word angle of depression, it's always the angle that's between the horizontal and the slant that's going down. So let's start off by drawing the slant that's going down. Now the 30 degrees, I said before, is going to be the angle between the horizontal and the slant that is going down. So I want you to carefully note where this 30 degrees is in the diagram, okay? And it's going to be right there, all right? So just to take a look at what we have so far. Again, we have a measurement of a side, and we have two angles based on the question we have here. And the question that we want to ask, and this is the part that's going to be challenging to figure out at first, is we want to find out the height of both buildings. Okay. So we're gonna, since we want to find out the height of both buildings, let's start off with something that's gonna help us get there. Okay, and what we want to do here is to solve for the height of the smaller building first. Because if you take a look at the height of the smaller building, okay, the height of the smaller building will actually represent the bottom portion of this taller building here. So we'll deal with that first, and then we'll proceed with the plan. So let's do that. Okay, so we're going to let S represent the height of the smaller building. Now I mentioned earlier when you're dealing with angle of depression, okay, there's actually a corresponding angle of elevation somewhere else in the diagram. So when we were dealing with angles, specifically angles of parallel lines, you learned what were called alternate angles or the Z pattern. So what we also have here is a 30-degree angle, okay, based on this triangle, which I've indicated there in the dark green. So what we have here would be a right angle between the building and this bottom line down here. Now, when it comes to the alternate angles, our 30 degrees will be located down there. Okay, so remember that was using what was called the Z pattern or alternate angles. So from this 30 degrees, okay, what we're going to do here is to label the S and 125 degrees with respect to that 30 degrees here. All right. So with that said, from the 30 degrees, remember that the side directly across from it will be the opposite. So when we take a look at the S over here, okay, the S here would be the opposite, and the 125 here would be the adjacent. So again, just like the previous question, we're going to use the tan ratio. Okay, and then just put the numbers in. So we have tan of 30 equals S over 125. Okay, and remember, since we're solving for the length of the side, we put that over 1, the tan 30 over 1 there, and then cross multiply. Okay, and when we put that in your calculator, the height of the smaller building would be 72.2 feet. Okay, so let's label what we have so far, because what we now have is 3/4 of the answer, so to speak. So we know that the height of the smaller building is 72.2. So this part of the taller building is also going to be 72.2. Now, um, I always um, I always tell students, don't trust the diagram, because people automatically think, well, that's just half of the other building, and the answer to that is no, it's not. Okay, the reason for that is if you take a look at these angles, you notice that this is 30 over here, and this one's 45. So this is actually just the bottom portion. The top portion of the taller triangle, taller building is actually taller than 72.2. So what is that height? Well, we need to figure that out. Okay, now I want you to take a look at what information we have here and just think of a plan. So notice what we have right now is just this bottom portion of the taller building here. And what we want to do now is find the total distance. So our next step over here is we need to figure out the height of the top portion of the taller building. All right, so let's do that. Okay, so the way we're going to do that, we're now going to use the top right triangle. Okay, and then from there, we're going to solve for that little thing that just came in the red there. Okay, so that's what we're solving for. All right, so we're going to designate that with a letter, and I've indicated which triangle we're going to use there, highlighted in the green. Okay, so we're going to let T represent the height of the taller building. Okay, so that part there. Now we're going to use here is 45 degrees, okay, and the sides that are given to us. Now you notice that this 125 degrees, 125 feet down here, okay, this length here is exactly the same as this one over here. So we just need to make a note of that as well, okay? So when it comes to the two sides here, we have to label the T and the 125 with this 45 degrees over here. And as you can see here, okay, the side directly across from that 45, okay, that T, this is going to be opposite. Okay, and the 125 here, that's going to be the adjacent. Okay, so we're going to use the tan ratio again. Okay, so when we do that, okay, we start off with the formula. Okay, put the numbers in. Now again, just like the previous example, since we're solving for the length of the side, you put the tan of 45 degrees over 1. Okay, and then from there, we cross multiply. And when we get that, we have T equals 125 tan of 45. which gives you 125 feet. Okay, so for the grand finale over here, we now have the bottom portion and the top portion. We just need to add those two, and that will give us a total of the height of the taller building. Okay, so the taller building will have a total height here of 197.2 feet. Okay, so whew, that was a little bit challenging at first, but again, make sure when you're reading the plans here, again, everything involves a right angle triangle somewhere in the diagram. Just know where those are here. And again, with this particular question, it's very important you know the difference between angle of elevation, angle of depression. And again, both of those angles are always going to be with respect to the horizontal. Okay, so this 45 degrees, remember, was the angle between the horizontal and the slant going up. Okay, and the 30 degrees, which we put down here, but before that, sorry, just gonna go back to one step over here. What we have here is a 30 degrees. Again, it's the angle between the horizontal and the slant that's going down. Okay, and we use alternate angles to solve, to label this as a 30 degrees when we're dealing with that problem there. All right, so the final problem that we're gonna look at here now, again, just to change it up a bit, okay, we're now going to be finding the measure of an angle. So we have a wheelchair ramp is needed at the entrance of a restaurant. And the diagram shows us that the ramp is 6.10 meters long and has a rise of 0.45 meters long. So what we want to do here is we want to figure out what the angle of elevation of the ramp is. Okay, so first things first, we need to identify where the angle is on this diagram. So if you take a look at the diagram, first of all, we have the two sides, which we're going to label in just a moment. And remember, the angle of elevation is the angle between the horizontal, okay, and the slant that's going upwards. So the horizontal part is actually the bottom side of this right angle triangle. And the angle of elevation is going to be right there. Okay, so that's going to be the angle of elevation. All right, so what two sides do we have there? Well, from this angle A, okay, the side directly across from it, that's going to be the 0.45. Okay, so that'll be the opposite. Okay, and as you can see here, we've labeled the hypotenuse first because it was a side directly across from the box here. Okay, so from there, since that's a hypotenuse, as I mentioned earlier, the side directly across from it, that will be the opposite. Okay, so now you have to take a look at all three ratios and see which one there has hypotenuse and opposite. Okay, and in this case here, you can see that's going to be the sine ratio. Okay, and let's put the numbers in. So the opposite here would be the 0.45, hypotenuse is 6.10. Okay, and from here you could divide the two numbers accordingly, and it gives you this. Now, as I mentioned before, when you're doing this step over here, when you take the inverse sine by pressing the second function, okay, and the sine over here, another method you could do here is to press the second function and sine first, and inside the brackets, do 0.45 divided by 6.10 and then close the brackets, and then that saves you from doing this step over here or this one over here. Okay, so the calculator will do that step all in one shot. Okay, so if you put this after you press second function and shift and sine, you put this in brackets and you divide it, okay, then you will get the same answer, which in this case here will be 4 degrees. All right. All right, so that wraps up this chapter, okay, and right angle triangles in general. So you continue working on the review, okay, and get ready for the test that's coming up, okay, and I'll see you in the next chapter.